All right, I'm going to do a quick little lesson on acid-base indicators, specifically how we're going to utilize Table M in this unit. So we mentioned a little bit in our first topic about the pH scale. So usually we consider it from 1 to 14 or 0 to 14, depending on the scale. 7 is a neutral pH. Okay, anything less than 7 is going to be acidic. Anything greater than 7 is going to be alkaline, which means that it's basic. Okay, the lower you go, the more acidic it is, and the higher you go, the more basic it is. And we'll be going over the pH scale coming up in the next topic. So in terms of acid-base indicators, these indicators will change color depending on if it's an acidic solution, a basic solution, and give us some idea of what type of material or substance we're working with. So pH indicators are chemicals that have a characteristic color depending on their pH. They can be used to determine if a solution is acidic or basic, or even to narrow the range of the pH of the solution down if we use and couple different types of indicators together. Now, something like this little picture showing us up above, this would be something like pH paper, and you're going to see this in the gizmo shortly. With Table M, these are ones that have really two distinctive colors that they change between. pH paper is you would dip it in, you'd match the color to the pH, and you get a pretty more precise pH that way. The indicators on Table M, again, you're going to see two distinctive kind of colors here. So a little bit with this little important note down here is that within the approximate pH range for color change, it's either going to be a mixture or a blending of the two colors. This is called like the intermediate color region. You're never going to have to determine the color within that range, only below it or above it. So like with this first example, and I think it's easiest to kind of understand how to use this table with examples, if I'm using methyl orange, the color change range is 3.1 to 4.4. So within that range, I might have something like orange or some variation of that. But what I do know is that below the range, it's going to be the first color. So it's going to be red. And then this is kind of like the 2. So this is like the intermediate. And above the range, it's going to be yellow. Okay. So again, when we read this chart, and we use methyl orange, if the pH of that solution is below 3.1, I would expect the first color written red. If it's above the approximate pH range for color change, it's going to be the second one, which in this case is yellow. And then between, we could say something like orange. Okay, but it's really what I have in bold there, below and above. If I look at thymol blue, okay, with thymol blue, we have this 8.0, and it changes through 9.6. So again, I only care really what's either color is going to be below that range or above it. So anything that's less than 8 is going to be the first color, yellow. Anything greater than 9.6 is going to be the color it changes to, which would be blue. So yellow to blue, meaning that again, below 8 is going to be yellow. And then above 9.6 is going to be the second color written blue. And then between there will either be some type of mixture or possibly a combination such as green. Okay, again, if you're looking at any of the other ones, just to practice this one more time, if I had like my phenolphthalein, my color change range changes from 8 to 9. So anything below that would be colorless. Anything above that would be pink. Okay, so if I had a solution that had a pH of 11, I would know that that indicator would be pink. Okay, if I had something like a pH equal to 2, that indicator would be colorless. Okay, all right, so we'll work on practice questions, but right now I want you to kind of focus in on the activity.